The first project is what we call the bathroom door latch. And this was a brainchild of one of our friends who thought that, you know, he was tired of looking under doors to see if a stall was empty or not, you know, and he was afraid to touch the door. And so he thought that that would make a great project, and it really gets into simple machines and a little bit of mechanisms to, you know, actually design something along these lines. So basically students are going to get a tamper-proof design going and figure out how to mount it into a door, and how the door would then latch to the upright. So there's a whole pile of different possibilities that the students could, you know, come across. And they also work on cabinets and regular doors, and I think students would get a kick out of designing something that functions. You know, that's one of those wonderful things about 3D printers and some of the other, you know, rapid prototype machines, that, you know, it's not just enough to create something, but, you know, it has a purpose, and that really helps students out. So the next one is a nutcracker, and basically you'd either assign the nutcracker or assign the bathroom door latch to groups of students. Sometimes it's a little easier in one form or another, but they're both designed to take about the same amount of time. And it's a miracle of modern design that, you know, we can give students choices and they can actually produce things that work. So in this case, you know, they're working on mechanisms, depending on, you know, what they feel like working with. And there's some tools that I'll show you a little later on to allow them to create gears and you know, other mechanical advantage devices. Then there's this ball launcher project, and the ball launcher project is, you know, covers things in much better you know, detail as far as preparing students for, you know, the college experience, because we're concerned with projectile motion, or our ability to predict the, you know, flight path of whatever we're launching. So the goal is to be able to hit a target, a 16 by 16 target that's placed anywhere within a certain distance range. So students have to build a device, then they have to perform several testing components, and then they can build an Excel graph that will show them how much force and what angle they should be launching at in order to hit a specific spot. So on the last class we did, there was a group that did this, and they got it down so they were consistently hitting a 6-inch square area, no matter where you put it. And so they would be able to go like, oh, we need this and this, and you know, it would, you know, land the piece in the box every single time. So that was pretty cool. And, you know, the using of Excel is really important to people that are getting ready to go into engineering technology, technical sales, anything along those lines. So there's a lot of career areas that depend on those skill sets. So we integrate that into the design process, because it's all part of design, doing that analysis and, you know, taking a careful look at how do our products actually function. So it's a great one for doing that deep testing. The next thing that we're looking at is the differential gear design. And it forces students into doing some research on, you know, what are these gears, you know, why are they used? and they're used all over the place. Anytime you have two rotating bodies that rotate at different speeds, we need a differential between them. So if you think about your car, when you go turning around a corner, one wheel has got to turn slower than the other because, you know, one is traveling a larger radius. So there's actually, you know, if you take a look at the circumference of a circle, you know, the further out you are from the center, you know, the more distance you're covering. So the differential allows two things to rotate at different speeds. And I'll show you a quick and dirty way to make gears. It's you know, there's a great function in the software that you just kind of basically outline what you want, and it gives you the gears. So the last project in this quarter is the merry-go-round. And there are literally hundreds and hundreds of different types of merry-go-rounds that we utilize in our playgrounds. And interviewing children about what they'd like to see is a real eye-opening experience. You know, one for the kids, because very rarely anybody ever asks them, you know, what they want to see and what they want to do. But secondly, the ability to communicate with a small person, you know, somebody who's 5 years old, their vocabulary is somewhat limited. So we have to, you know, work on, you know, translating technical issues down into understandable language. And when you take a look at technical sales, that's a huge component of it. As we go out there to, you know, sell everything from, you know, power plants to artificial knees to just about anything that we deal with on any kind of a basis, there's somebody who has to go and explain that to their customers. So, you know, every school district has their bus garage, and somebody comes in there and you know, make sure they have the proper tools and that the buses are running properly and they get the right you know, support. So the ability to talk to your audience is critical. And that's another thing where you have to really work on students. So when they're doing their presentations to all the, you know, the quote unquote authentic audience, you know, that they learn how to converse with them at their level. And, you know, so that takes a much greater knowledge of what you're really talking about than just writing a report. So presentations are important.